This is a group project between Reese and Sergio for our Video 1 essay coursework. We will be analysing and responding to Conversation 2 about quantum computing and cryptography. As this is a group project, we have contributed equally to this assignment, and we will be assuming the roles of Max Planck and Erwin Schrödinger in a follow-up conversation where both individuals have done more research into the field of quantum computers.
Hello, Erwin. You remember the conversation we had about quantum computers?
Yes. After the conversation, I actually went away and did some research on the topic.
Well, after doing some research as well, whilst I do believe that if a criminal organisation gets a hold of a quantum computer, they could definitely cause some chaos, I do not think they are as powerful as we initially thought them to be.
I remember you saying that a quantum computer are powerful because of the quantum units known as qubits. From what I've researched, they are small particles inside a quantum computer that are able to store bits of information. These qubits are also in a state of quantum superposition, where they are both true and false until measured. Once a computer measures these qubits, they will then decide between true and false and return one of the two values. This is possible because qubits are able to store the equivalent of 2 classical computer bits, which is one of the things that makes them so powerful, and as such allows one qubit to store both a 1 and a 0 simultaneously.
The process makes it so that quantum computers have vastly more computational capabilities than a standard computer. It is much like the concept of your cat theory, where you look inside the box and the cat will then move from its superposition of being dead or alive. This does indeed mean that if a criminal organisation got a hold of such a powerful device, they could definitely cause some havoc. While I did say in our previous conversation that they're powerful enough to break cryptographic algorithms, after doing more research, I discovered that that's not always the case. Quantum computers are vastly superior in some fields. They are also not as versatile as normal computers. A popular encryption that is said to be cracked by the quantum computers is the RSA public-private key algorithm. This is a bit misleading. Whilst they have been cracked, the RSA algorithm, they cannot crack the standard quite yet because a lot of qubits inside the current quantum computer are used for error-correcting code. And as such, we need to upgrade quantum computers to crack the current RSA standard of 2048 bits.
I've learned about this. The capability for quantum computers was only made possible by American mathematician Peter Shaw, who wrote a quantum algorithm that can find the factors of a prime number, which is the backbone of the RSA encryption method, which classical computers simply cannot break. However, not all hope is lost, as a criminal network with a quantum computer couldn't ruin our security systems because some security experts have created quantum codes for the RSA algorithm, which even a quantum computer could not beat. And whilst these are not yet standard in the industry, they are ready for implementation. Therefore, a criminal organisation would not have infinite power.
I'm certain that we would have to investigate all the commonly used encryption methods used in the industry and find which ones are at risk. With quantum computers, we will have to throw away encryptions that are too weak to survive, and switch to new methods or methods capable of countering a quantum computer. For example, there may even be scenarios where we would have to use quantum computers to counter attacks made by other quantum computers. Whilst a criminal organization might not end the world, they would have a massive impact on the security systems and encryption methods used around the globe.
I do remember that you said that we can make quantum chatbots to fool people in social engineering scams. That may or may not be the case. Standard computers are already able to make incredibly powerful AI using machine learning. I do think that quantum computers could do this. I think they can make AI faster, but not necessarily better. Quantum computers are great at doing very specific tasks. One of those tasks being sorting through large SQL databases, seeing as normal computers need to go through each entry at one time. Quantum computers take a square root of that time to do exactly the same thing.
So, quantum computers are incredibly powerful, but much like other devices, they have their own strengths and weaknesses. We should do some more thorough research into this and see what more we can find out, for this is merely the tip of the iceberg.
Indeed. Although we have done some research on this topic, we could do more if the option is available.